Hey everybody, this is Mr. Palacios here. Today we're going to be talking about turning quadratic equations into quadratic formulas and then using that to solve your quadratic equations. So we're going to start off with a standard form quadratic equation a times x squared plus bx plus c equals 0. We're going to subtract c from both sides so that we get it like this. And then we're going to multiply both sides by 4a to make the coefficient of x a perfect square. So we're going to get 4 times a squared times x squared plus 4 times a times b times x, and that's going to equal minus 4 or negative 4ac. And then we're going to add b squared to both sides to complete the square, and then write it as the square of a binomial. So we're going to take 4 times a squared times x squared plus 4 times a times b times x plus b squared equals negative 4 times a times c plus b squared. And when we factor that out, that's going to become 2 times ax plus b squared, and that's going to be equal to b squared minus 4 times a times c. Now we're going to apply the definition of a square root to solve for x. So when we do that, we're going to get the square root of that, which is 2 times a times x plus b equal to plus or minus the square root of b squared minus 4ac. We're going to subtract b from both sides in order to isolate that x. And what we're going to get is 2 times a times x equals the opposite of b, or negative b, plus or minus the square root of b squared minus 4 times a times c. Now we're going to divide this side by 2 times a, which means we need to divide this side as well, and that's going to help us isolate that x. And so what we're going to find is that x equals negative b plus or minus square root b squared minus 4ac divided by 2a. And this is the quadratic formula. You see I wrote equation there, messed up, formula. And for any quadratic function written in standard form, boom, boom, the quadratic formula gives the solution of the equation. So we can use this to solve our quadratic formulas. So let's take a look at a couple of examples. Before we do, I want you to know that there's a thing called the discriminant. And in x equals negative b plus or minus square root b squared minus 4ac all over 2a, b squared minus 4ac is the discriminant. So this is just everything within that little radical formula, right? That little radical right there, b squared minus 4ac. And we're going to call that d for discriminant. If d is equal to b squared minus 4ac. So there's a couple things you need to know about d, about this discriminant. If d is greater than 0, there are two solutions. Minus b plus the square root of d over 2a, and minus b minus the square root of d over 2a. And that over obviously means divide. If d is equal to 0, then there is one solution, minus b over 2a. You should have seen this formula before in previous lessons. And then if d is less than 0, that discriminant is less than 0, then there are no solutions because the square root of d is not a real number. Okay, so we're going to take a look at a couple of these so that you can kind of get the hang of this. Now, if b is 0, then a couple of things happen. If a and c have opposite signs, then there are two solutions. You have the positive square root of negative a times c divided by a, and then the negative square root of negative a times c over a. If c is equal to 0, the only solution is 0. And if a and c have the same sign, there is no solution. If c is equal to 0, so now we're getting into different territory here, but if c is equal to 0, then x equals minus b plus or minus the square root of b squared over 2a. And because b squared is equal to the absolute value of b, the two solutions are 0 over 2a, which is equal to 0, or 2 times b over 2 times a, and that's negative. And so our answer is negative b times a. Okay, so that discriminant can affect the outcome of the equation. So can b if b is equal to 0, and so can c if c is equal to 0. So as you go through, you're going to see all the different variations of this. And as we practice these, you're going to see, oh yeah, that's what happens. That's when the discriminant is greater than 0 or equal to 0. Okay, so let's take a look at a couple of examples. All right, so our first one, 6 times x squared plus 5x minus 4 equals 0. Our a value is 6, our b value is 5, and our c value is negative 4. So we're going to plug that into this quadratic formula. So remember, that is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 6 times negative 4 divided by 2 times 6. When we work that out, that is x is equal to negative 5 plus or minus the square root of 25 plus 96 all over 12. And x is equal to negative 5 plus or minus the square root of 121 over 12. And x is equal to negative 5 plus or minus 11. 11 is the square root of 121 over 12. And so now we have two options here. These are our two solutions. If 11 is positive, you have negative 5 plus 11 over 12. That is 6 over 12. And so x equals 1/2. If we have negative 11, you have negative 5 minus 11 over 12. That comes out to negative 16 over 12, which is negative 4/3. So x is equal to negative 4/3. So these are our two solutions. Okay, and again, because d is greater than 0, we have two solutions. Okay, let's take a look at our second example here. You have x squared plus 7 equals 4 times x. And we want to subtract 4x from both sides to write it in standard form. So we're going to get x squared minus 4x plus 7. You took away 4x here, that gives us 0. Take away 4x here, that gives us this. And so our a is equal to 1. There's nothing in front of x, so that means that it's 1. B is equal to negative 4, and c is equal to 7. So let's plug that into our quadratic formula. Okay, and so we have x equals negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 7 over 2 times 1. So x equals negative 4 plus or minus the square root of 16 minus 28 divided by 2. And so that simplifies into x equals negative 4 plus or minus the square root of negative 12 over 2. Because the discriminant is negative, there is no real solution. So we can stop right there. Let's practice one more just in case you thought you were getting the hang of it. 5x squared plus 9.8 equals negative 14 times x. We want to write that in standard form, so we're going to add 14 on this side and add 14 on this side, which is going to give us 0 on this side, and this side is going to equal 5x squared plus 14x plus 9.8. So x, let's plug these values into our quadratic formula. X equals negative 14 plus or minus 14 squared minus 4 times 5 times 9.8 over 2 times 5. So x equals negative 14 plus or minus the square root of 196 minus 196 over 10. And so now we have x equals negative 14 plus or minus the square root of 0 over 10. And x equals negative 14 plus or minus 0 over 10. The discriminant is 0, so there's one solution, and that is negative 14 over 10 simplified. X equals negative 7 over 5. All right, so that's the quadratic formula in a nutshell. And just because I want to get a song stuck in your head and I have about a minute to go, I want you to think about Pop Goes the Weasel. I don't know if you ever heard it before, but this is the jingle that you can use to remember the quadratic formula, and that is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, again, that is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Sing that song. Get to know it and enjoy working on additional practice, and problem solving. This has been Mr. Palacios. I enjoyed this video. This is my favorite one of all. Have a great rest of your math period, and I'll talk to you later. Peace.